Alright, so in the last video we went over just the basics of amplitude phase form. But now we're going to actually do an example, so if you were confused, this will hopefully help. So basically what we want to do is find an equation that expresses a spring that has a mass of 2 kilograms. So the mass is 2 kilograms, and the spring constant is 18 newtons a meter. But there's no damping constant, so there's no friction. So this is just going back and forth endlessly. So we also have some initial conditions, so we can find some constants. And well, let's jump right into it. So let's plug in our constants. So we get m equals 2, so 2x prime prime plus, well, this is undamped motion, c equals 0. So we can just ignore this, plus 18x equals 0. And in a few videos from now, we're actually going to do some questions where this doesn't equal 0, which means there's like an extra force acting on the mass. But for now, we're just going to take baby steps. But as we do, we want to factor this out. So 2r squared plus 18. And well, we end up getting r equals the plus or minus of square root of negative 18 over 2. So this is just r equals plus or minus 0, r equals 0 plus or minus, well, the square root of negative 9 is just 3i. So I added the 0 here because alpha just equals 0, and this beta equals 3. And beta is the same as omega, where omega is just the square root of k over m. So one thing I want to point out is alpha and this constant a are completely different. However, beta and omega are the same. But let's jump right into it. So we got beta equals 3, or omega equals 3, and alpha equals 0. We have complex roots, and well, you know what that means. We gotta use that ugly ass formula. But first, let me just write the definition of omega right there, just to keep it handy. My writing is off today. But for complex roots, actually we're gonna do it up here. Complex roots, we got something of the form e to the alpha t times cosine c1 cosine of beta t, but we're going to write omega t because we do plan on putting this in amplitude phase form, and beta is just omega. c2 sine of omega t. And well, we have two initial conditions, but one is expressed in the derivative, so we will need to find the derivative. But first, let's just plug in our constants. So x of t equals e to the 0t, and well, e to the 0 is just 1, so we can just completely disregard that. So our equation actually simplifies a lot to just c1 cosine of 3t plus c2 sine of 3t. And well, now I want to find the derivative. So let's do that. The derivative of cosine is just negative sine. So negative c1 of sine of 3t. Then we have a little bit of chain rule, so the derivative of 3t is just 3, plus derivative of sine is just cosine, so c2 cosine of 3t times 3, just a little bit of chain rule. So that simplifies to negative 3c1 sine of 3t plus 3c2 cosine of 3t. So now that we have that, we can plug in our initial conditions. So hopefully it doesn't get too messy, but x of 0 equals 1. So let's plug that in. 1 equals c1 cosine of 3 times 0 plus c2 sine of 3 times 0. And cosine of 0 is just 1, and sine of 0 is just 0. So this cancels out, and this equals 1. So we're just left with 1 equals c1. Now for here, let's rewrite this nice and neatly down here. The x prime is negative 3c1 sine of 3t plus 3c2 cosine of 3t. And, well, we're given the same initial condition just for the derivative x prime of 0 equals 1. So let's plug that in. Equals negative 3 c1 sine of 3 times 0 plus 3c2 cosine of 3 times 0. And again, sine of 0 is just 0, so that cancels out. And we're left with just 1 equals 3c2. Cosine of 0 is just 1, so we can write the multiply by 1, but it doesn't change anything. So c2 equals 1/3. Now let me just check with my notes real quick to make sure I didn't make any mistakes. And we are all good so far. So let's continue on. And, well, we know omega. We know our constants, so we can actually work our way towards transforming this ugly expression into amplitude phase form. And, well, again, omega is k over m, or it's just beta, but let's just plug in our values. So k is 18, m is 2, we get the square root of 9, which is just 3. So omega is 3, and a is just the square root of c1 squared plus c2 squared. Where does that come from? I don't know. Khan Academy probably knows. You should watch him instead. But we have c1 equals 1, c2 equals 1/3. So 1 squared plus 1/3 squared. The square root of that equals radical 10 over 3. And phi is defined as the tangent inverse of c2 over c1. So let's do that. Tan inverse of c2 over c1 is just 1/3 divided by 1 is 1/3. So the tangent inverse of 1/3 equals, let me get my calculator, it's going to equal 0.32175, roughly. And that's in radians. And we do write phi in radians. But there's another thing we need to consider. The domain of tan inverse is only defined on the right side of this hemisphere, the right side of the unit circle. So from negative pi over 2 all the way to pi over 2. That's where it's defined. And tan inverse has to be positive. So, well, we can find out which quadrant this is in. It has to be in either quadrant 1 or quadrant 4. And, well, one sec. So, we know that C1 is greater than 0, and C2 is greater than 0. And should be pointed out that C2 is kind of just like sine of phi, and C1 is cosine of phi. It's something like that. It might not be 100%, but if we have like sine and cosine of phi, like the x and y axis, if they're both positive, then this must mean that it's in quadrant 1. So it is in the domain. So that's good. And we got 0.32175, which is positive. So there's actually nothing we need to do here. We just leave phi as is. But say this was negative, then we would have to add a pi. That way, well, we'd add 2 pi so it goes all the way around, but now it's still in the domain, does a whole rotation, but now it's positive. If it was on this side and like positive, we just add 1 pi. So now it's on the other side of the circle. It'll make more sense as we do more examples, but let's finish this up. So we have our amplitude phase form of x of t equals a cosine of omega t minus phi, and x of t equals, well, a is radical 10 over 3. Cosine of omega is square root of k over m, which is the square root of 18 over 2, equals 3, times t minus phi, which we found to be 0.32175. And we didn't need to add any pi, 2 pi, or just 0, because it's in the domain and it's positive. So this would be our final answer.